If you are good, just confirm that you can hear me. Okay, okay, 3 confirmations. Okay, okay, I think, okay. We can continue. So, we were here, we're discussing how we can actually filter vectors with multiple conditions, using the AND operator or the AND symbol. So one thing about these AND symbols is whenever you are using them, you must make sure that at least one of the conditions that we want is met. And at least we must make sure that the 2 conditions are met. The 2 conditions must exist before it will work. Like in this case now, we checked for values x vectors, elements in x vectors that are less than 5, and we also checked for elements in the same x vectors that are greater than 2. So the AND operator here ensures that these 2 conditions, they must be met before I'll give you an output. That is just what it is. Without one of them being met, we won't get the desired output. So that is where the OR operator comes in. This particular symbol here, this particular straight symbol here is OR in R language. So still on the same conditions, we are checking for numbers that are greater than 2 and are less than 5. So when we did this particular AND operator, when we're filtering with this AND operator, combining conditions, you notice that the result was 3 and 4. So because 3 was greater than 2 and then less than 5, and 4 was greater than 2 and then less than 5. So that is what that and there takes care of. So the OR, whenever we are using the OR operator, both conditions or any number of conditions that we're doing that we want to combine together, one of it has to be met before the desired output will be shown to us, or before we get the desired output. So like in this case now, vector elements in this vector S that is greater than 2, or element in this vector S that is less than 5. So when we do this now and Control Enter, we discover that you are getting the whole vector itself. Remember, this is the whole vector. 1, 2, 3, 4, 5, 6. So we are getting it because from here, 1 is not greater than 2, but 1 is less than 5. So that is why 1 is here. One of the conditions must be met. So I hope that is clear. So let's see what happens if one of the condition is not met in this AND case. Like we want to see values that are greater than 10, let's say 10, and then and are less than 5. There is elements in the S vector that are greater than 10 and are less than 5. Let's see if we'll get any output. Okay, so we see something like this, numeric 0. This is just telling us that, okay, this condition is not it. We don't have any condition like that meets. We don't have any particular element in this variable or in this vector S that meets that particular condition. So that is why we are getting this result. So one of these conditions is met here. That is, there are values in this vector 1, 2, 3, 4, 5, 6 that are less than 5. These values, they are less than 5. But since the other condition is not there, like there are no values that are greater than 10, we are not getting output. So we can do that now. We can fix that by, like, say we want to check now with the OR operator. So values, elements in the S vector that are greater than 10, or elements in the S vectors that are less than 5. But we already know that there are no elements in this vector that are greater than 10. But since we are using the OR operator, and OR operator allows us to filter when just a single condition is met. So we are good to go. So when we run this particular code, we see that we still get a result 1, 2, 3, 4, 5, even though this particular condition doesn't exist. So I hope that is clear for conditioning and filtering. So let's move on. So initially, earlier on, we saw that to access an element, we can use the position. Like if we know where certain elements are in a vector, we can use the position number to get that element. We can use it to access the element. When we're doing something like, when we're using the when we're doing something like this, yeah, want to access the second element of the vector V. So it will give us the element A as the second vector. Remember that, as the second element. So if we do not want the element, like we know the elements that we're looking for, this is very, very important. Very, very important. There are times that you have lots and lots of data, like vector like that. You have lots of them, but you know some of the elements in that vector. But you want to know where the position, their position, where they are in that vector, where they are located. So you can use a function, which. So which is another base R function. It's inbuilt. You have it pre-installed when you install R and RStudio. So which function gives us the position of elements in a vector. So that is just what it does. So here I want to create vector T with 10, 20, 30, 40, 50 as its element. So I want to know the position of this 40. So since this vector is not huge, it's not long, it's not big, we can just look at it ordinarily and, okay, count 1, 2, 3, 4. This particular element is in the 4th position. But just imagine a case or instances where you have vectors that has more than tens of thousands. Okay, if tens of thousands is too much, okay, maybe say 100 or 50s or 200 elements like that. I want to get position of certain elements in the vector. So that is where you can always use the which function, because you can't just go and start counting from these things so to know the position. So in that case, the which function enables us to just do it very, very easily. So after creating this vector now, we can check the position of the 40 element. When I control enter, you see that I'm getting a result in the console, 4. And that is right, because when we start counting from here, we have 1, 2, 3, and 4. So that's just that. We can do for 20, want to check the position of 20, and you see that the result is 2. It's also correct because 20 is in the second position. Check for 30 as well. Sorry. Yeah, yeah. In this case, we were using the equal to, we want to see the values that, the elements that are equal to 40, about the position. And we did the same thing here, only that in this case, the element we are looking for, the position is 20. So now we want to look for elements that, we want to look for the positions of elements that are greater than or equal to 30 in this particular vector. So that's why we are using this greater than, equal to. Yeah, we learned about this operator earlier. So from here, we can easily just see that 30 is greater than or equal to 30, 40 is greater than or equal to 40, 50 is greater than or equal to 40, 50, 30. So, and their positions are, okay, start counting from here, 1, 2, the third, fourth, and fifth position. So that's why when we ran this line of code, we got 3, 2, and 3, 4, and 5 as the position. So now, if we want to do what we did earlier, if we want to just make everything like, we can just come here and say T square bracket, we want to access with the C bind these values, as in the values in these positions, the elements in these positions. We learned this earlier. So you can always do this and then Control Enter. We see that, yeah, we are getting the actual element when we use the element position to index with this syntax that we learned earlier. So I hope this is clear. Okay, so going further, please ask questions if you are not clear. Ask questions. Okay, so going further, there are other ways that we can use in creating vectors in R. It doesn't just limit us to using the C bind or the C combination function. It doesn't just limit us. We can also create vectors using this colon operator here. So this in this case is just like a range. We want to get values that spans from 1 to 10, from the range of 1 to 10. So these values will come out as a vector. This is another way to create vector. But the problem with this one is you cannot do multiple different values. They must follow certain range. They must follow the range that you indicate. So that is the limitation. That is why we don't use this method mostly. It's only when you want a range of things that you use this method to create a function. So the C function is the best way to create functions. So other easy ways for us that we can create vectors is, okay, we have rep. There is this function rep, replicates. It stands for replicates. So this function takes in 2 arguments. The first one being what we want to replicate, and the second one being the amount of time that we want it to be replicated. Okay, there are other arguments, but these are the 2 arguments that will concern ourselves with for now, since we are talking about creating vectors. So we can also use this method to create vectors. Okay, so let me run this first line of this range. So we can see that created vector 1 to 10. So the range is 1, 2, 3, 4, 5 is giving us the value. We did not necessarily or explicitly have to write this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This column here helps us to do away with that stress. So the rep function, in this case now, we are replicating 1 5 times. So let's run Okay, so you can see we have a vector of ones as its element. So that's another way to create. So another way is sequence. This stands for sequence. Is a way to create. These are just simple, easy ways that some people have uh, created a function for us to be able to create vectors and use. Okay, so in this case, this sequence takes in lots of arguments, but we'll concern ourselves with just three. The first argument is the starting point. The second argument is the ending point. And then the third argument is the steps of the sequence. So we want to create a sequence starting from 2 to 10, but we want the steps to be 0.5. So let's run this now. I'm still creating a vector, remember. So Z, so our Z is now 2.0, 2.5, and so forth. So that's another way. These are vectors. This is a vector, sorry. This is a vector. This is another way to create vector. And then another function here, sample. The sample helps us to create random numbers. Like they help us to create random numbers. In the Excel, I think it's round between, something like that, round between, and then you give it a range. Okay, so that is what this function also does. To indicate the size, yeah, will indicate the size, the range of the random numbers that I want to create, and then we'll indicate the size. This is the size. So we want to create random number between 1 to 20. So we do not have to explicitly write something. We do not have to write something like this, 1 to 20. It just automatically knows that this is what we mean. And then the size will be 10. Just 10 numbers that are random between 1 to 20. This is also a way to create vector of random numbers. So we see that we have our numbers, the size, we have 10 numbers here and they are random between 1 and 20. There are still other arguments that we can pass into this function, but that is not the idea of this class. So there is a replace argument that you can pass, but that is not what we are concerned with now. We just want to see other ways to create vectors. So moving on, we have matrices. So this is also very, very important. This is very, very important as well. If we'll be working with data frames and tables, we need to know the idea behind the structure and all that. So a matrix is a collection of data elements of the same type arranged in two-dimensional rectangular way. Yeah. So it's rectangular in shape. I did not complete this statement. So it's two-dimensional and it's rectangular. So I hope we can all picture that, like it's rectangular. And we all know, I believe, I'm hoping we know what matrices are. Okay, so we can create matrices using the matrix function. So this is the function. This is another base R function. It comes pre-installed. We do not have to create it ourselves, and we do not have to load packages or install packages to be able to use this function. So a matrix, and then the arguments are the vector that you want the matrix to contain. So you have a vector, and then the number of rows. This n row here stands for number of rows, and the n column here stands for number of column. So this basically is, we are trying to create a matrix with elements 1, 2, 1, 2, 3, 4, 5 to 6. I want the number of rows to be 2 and the number of columns to be 3. So let's do this and see. So when we run this, we see that the matrix has been created with that function matrix. So that's that. But one thing about creating matrix this way is that whenever you create a matrix, it's usually column wise by default. Column wise by default. I don't know if you understand. So like in this case now, 1, 2, 3, 4, 5, 6. We are creating this matrix now. So since the number of rows that we want is 2 and the number of columns is 3, so we are our output matrix will be 1, 2, these first two values, and then 3, 4 in a row format, in a column format, 3, 4, and then 5, 6. So most times we may not want it that way. We may want our matrix to be by row, like 1, 2, 3, and then come down 4, 5, and 6, and so forth. So we can do that by using an additional argument in this same matrix function. So we want to create the same matrix, but this time around we don't want it to be column wise, because by default this matrix gets created column wise. So now we want it to be by row. So that's why we are adding this argument. Well, we did not invent this argument. This argument is there in the function. When the person that created this function, when he was creating it, he added this argument for us to be able to position the matrix the way we want. So I'm adding this by row function and argument now and setting it to true, so that our matrix will not come in the by column format. So you can see that it has changed. It is no longer 1 and 2, 3 and 4, 5 and 6. It is now 1, 2, 3, 4, 5, 6 in a row form like this, in a row form. So that's just that. So going further, so it is not necessary to specify both the number of rows and columns when you are creating a matrix. It is not necessary. R is smart enough to be able to do that for us as far as we indicate just one of the two parameters. What I mean is, you see, initially we did something like n row, number of rows, to number of columns, 3, but we do not have to do that. We can just go ahead and say number of rows 2, and then R will be smart enough to know that, okay, if the number of row is 2, okay, then automatically the number of columns should be 3, because we only have 6 elements in this particular vector that we want to use in creating the matrix. So that's that. So, and whenever we are indicating the number of row or the number of column, because instead of number of row, I can also do n column, and put any number there, 3, and I will not indicate that of the row. R will automatically do that for me. So, but we must make sure that the number of vector, that is the length of the vector, must be a multiple of the number of row or number of column that we are specifying. Must be a multiple. So you know that 2 is a multiple, and 2 times 3 will give you 6. 6 divided by 3 will give you 2, and then 6 divided by 2 will give you 3, and all that. So that is what it just means. So it must be, that condition must be satisfied for it to be able to create the matrix the way you want. So okay, so Okay, let's try a number. Once you try in once sorry, let me run this particular line of code and let's see the output first. So we see that we are still getting the same result even without specifying the number of column and number of row. We only specify the number of column and it worked. So moving further, we want to now create a vector with 7 elements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I should add 6 and then 7. We want to create a vector with 7 elements. So we know, and we are indicating that okay, we want 2 rows. So if we think of it, you know that 7 is not a multiple of 3, and sorry, 2. When you divide 7 by 2, you have decimal places and all that. So there's no value that you can just say okay, two times. There's no integer value that you can say 2 times that will give you 7. So it's not a multiple of 7 is not a multiple of 2. That is why when you try to do something like this now, okay, when R computes 2 rows for us, what will happen to the remaining 5 elements in the vector? So let's see what happens. So I'm trying to I've just run the code now, and you can see that there's a warning. In metrics, this. Data length 7 is not a submultiple or multiple of the number of rows 2. So this is just telling us what I'm just saying. So, but it's not as if this matrix will not get created. It actually gets created. Let's confirm that it was created. This is just a warning. So let's see the implications of doing it that way. So okay, you can see now that if you notice, we had 1, 2, 3, 4, 5, 6, 7. So our elements now became 8. R automatically added this one for us just to complement the number of columns that will not be right. We indicated that we wanted 2 rows, but if we are working like this, then it means that we will have 3.5 columns remaining, and we cannot have that. So R automatically made sure that the columns becomes 4, but the value, the element will start again from the first element here. I don't know if that's clear. So 1, 2, 3, 4, 5, 6, 7. So R added another one again automatically for us like this, so that it becomes like this. We have something like this. So whenever our vector is not a multiple of the number of row or column we are specifying, R automatically computes the remaining values to complement the number of row or the number of column that we want with the starting values. Like if the remaining values are 3, so R will make sure that it uses this 1, 2, 3 as the subsequent values elements that will follow in this matrix. So I hope that's clear. So moving on, we can, just as we did in the earlier class, we can check the class of the matrix. We can check the class of this variable. You know, we created this matrix and we're assigning it to this variable m. So we can check the class to confirm that it's a matrix. So we'll do that, and we can actually see that it's coming out as a matrix. Yeah, it's coming out as a matrix. So we can check the type of, and we'll see that it's a double. We did not really talk about double, but don't worry yourself about it. maybe for later on we'll talk about it, but for now, still know that the double is a subset, or yeah, is a subset of numeric. They are all numeric values. They are all numeric values. So the whole M variable that has this matrix inside of it is a matrix, but the values are numeric. So just know that. So we can check the dimension of a matrix with the dim function. So we just write the dim, then in brackets we pass in the variable that has the matrix, like the variable that we created. And then if we do that, we see that, okay, yeah, we have 2 rows and then 4 columns. And that confirms, yeah, that's right, because here we see that we have this first row and another row, which makes it 2. And then the columns, we have 1, 2, and 1, sorry, 2, 3, 4. So the dimension function tells us the number of rows and the number of columns of our matrix. So this is important because it's still, all what we are discussing here still applies to data frame when we start looking at the bigger pictures. So that is why it is good we know about these things from the foundation, so that when we start working with complex and bigger, uh, uh, when we start doing complex or bigger activities, we'll see how these things come together. So we can use the n row function to check the number of rows, and we can use the n column function to check the number of columns in the matrix. So take note. So we can also create matrix using the rep function. The rep function that we just saw a few minutes ago. Can also use it to create vector and the matrix. Sorry. So we are using this rep function to create a vector here instead of using that C bind. That C is we're using the rep function, and we are saying, okay, we want the number of rows to be 3. So we want what this is okay. We want to replicate 8 9 times. So let me just select this particular. You can actually select a chunk and then run it with the control enter without having to run the whole code, the whole line of code. You can just select fraction, like a fraction of the code, and then run. So we are replicating 8 9 times. So this is the result. So we want to create a matrix with this particular vector now. We want the number of rows to be 3. That's just what this is, nothing special. And then we are using the matrix function to make it a matrix. So let me just run it, saving it inside the variable A. So we can look into that variable and see that, yeah, we've actually created the matrix with 9 A's having 3 rows and 3 columns. Notice that we do not have to specify the number of columns. We only had to specify the number of rows and add the remaining thing for us. So we can also use the sequence that we learned earlier to create matrix. So we use the sequence to create a vector and then indicate the number of rows that we want, and then we'll tell it that we want it by row, and then just same thing we just did earlier. So we are just adding everything together to make sense out of them. So that's just what we are doing. Sorry, let me run this code. Okay, so I'm checking the B. You see that I've created a variable. It's a matrix of sequence 1 to 5, and the length of the sequence should be 15. So that's just another way. So matrices does not necessarily have to be only numeric values. They are not restricted to being only numeric values. having only numeric values or numeric elements. So we can have matrices that comprises of um, characters. So let me run this line of code. I'm creating this variable C matrix, and I'm using the matrix function to create a matrix with a vector. This particular letters, this letters here, if you run it in your RStudio, is inbuilt, is an inbuilt vector that is just there for us. So if you run it, you see that it comprises of letters, characters, and letters A to Z. So that's just what I'm trying to use it now to create a vector, and using the vector to create a matrix. And I want the number of row of that matrix to be 2. So let's check on this particular matrix that we just created. You see that, yeah, actually it created it, and we see we have 2 rows and then about how many columns? 13 columns with the alphabet A to Z. So that is just what it does. We can also create metrics with logical elements. So this is just showing you that matrices are not limited to only numeric values. They can be character, they can be logical, and so forth. So creating this thing using the same rep function and to create true and false, and then I run this line of code, Control Enter. You see that we have created a matrix that has 3 rows and then 2 columns with trues and false. That is just what it is. I hope we are clear. Okay, moving on. We can create metrics with the rbind function. There is a function in R, base R, pre-installed. Most of the functions we are dealing with in this class are there for us. We do not have to install any special package or create functions. They are just available for us to use. So remember what we learned earlier about creating vectors using this column operator. So we are creating this vector now from the range 1 to 6. So let me run, and we're creating another vector from the range 7 to 12, and we are creating another one from the ranges 13 to 18. So let me just highlight this. Let me just highlight these particular 3 lines and then run them. We've created these 3 variables now. So we want to create a matrix out of it. So in this case, we do not necessarily have to use that matrix function that we've been using to create a vector, to create a matrix. What we can just do is use the rbind. This rbind here stands for row bind. So we want to combine these things row-wise, and then automatically R will recognize that, okay, this thing looks like a matrix. Let me just make it a matrix. That is what this is. So let me just run this particular chunk and then check it, the variable. We see that these 3 variables that we just created, A having element 1, 2, 3, 4, 5, 6, B having element 7 to 12, and then C having element 13 to 18, combines together to form this ABC with the rbind function in R. So let's check the class of this particular matrix that we just created to confirm that it's a matrix. You see that it's a matrix, even though we do not use this matrix function. R automatically knows that. R is very, very smart. So going further, the row names. So if you notice, when we're creating our matrices, the row names are usually the indexes. Like, see this case now, there's the first row here is 1, the second row here is 2, the third row here is 3. And the first column here is 1, the second column is 2. So these names are automatically assigned to our matrices by R. But sometimes we may not want it to be that. We may want to, okay, we want to make meaning of this data. So let us give our row names. Though when we are creating with a matrix with this R bind function, R automatically makes the variables the name of the rows. So if you note, you can notice, I believe you can see that here in this particular matrix that we created, A takes the name, A stands for, like A is the name for the first row, and B is the name for the second row, and C is the name for the third row. This is what R was able to do for us when we're using the R bind. But we can change these names, we can modify this name depending on how we want the metrics to how we want the output to be. So there is the function row bind and row names. The function row names helps us to change or modify the name of a matrix, not just a matrix, a data frame. But since we are dealing with matrix here, we can use this function to change the row. So this is not out of what we've been learning so far. I'm just creating a vector with 3 elements, row 1, row 2, and row 3. So I want to make those 3 elements to be the names of this particular ABC matrix that I created. I hope it's clear. So that's just what it is. So one thing to note is that if we are naming the rows, we must make sure that the names, like the elements of this vector, must match the number of row of the matrix that we created. Like in this case, since our matrix has 3 rows, 1 row, 2 row, 3 rows. So our elements of this vector must be 3. So that's why it's like if we create a matrix with 3 rows and use and give it a name with a vector that has more than 3 elements, we'll get an error. So no names will be assigned. So that's why it is important to know the length and then work with the length like that. So I'm running this line of code now, changing the row names. So let's check to see if it actually worked. So we can see that the row names are now, instead of the ABC or the 1, 2, 3 that we had earlier, it has now become what we indicated here: row 1, row 2, row 3. The same thing applies to column. We can also change the column names. Instead of this 1, 2, 3, 4, 5, 6 in a square bracket that we are having here, we can just say, okay, we don't want it to be that. We want to name these columns ourselves. So we are doing it using the column names function. This is another function that is available for us in R. So just as we did, but in this case, you know that the number of columns here are 6. So we must make sure that the length of this vector that we are creating, the element, must be 6. So let's check to see if that's actually worked. Okay, so it worked. Column 1, column 2, column 3, column 4, column 5, and column 6 are the names of this matrix now. So we can see that we've been able to redesign this matrix to our taste. So going further, I don't know, our time is no longer on our side. I don't know if we should continue to 12:30 or we should just end it here and then maybe in the next class we'll continue. Okay, so let's just continue. maybe till 12:30. But I'll try to rush things up from here, because most of the things that we'll need further on is what we've already learned. Like we've already learned them. So we want to we'll be using them in a more advanced, not advanced per se, but in a more um, complex way. Let me say it that way. So indexing matrices. So the square bracket can be used to index the elements of the matrix. We've learned this, I believe, when we're doing vectors, when we did vectors, sorry. We're able to index vectors with this square bracket. So we can do the same thing with the square with the matrix. We can do the same things in matrix. But in this case, since matrix is two-dimensional, we have to provide value, the position for the row as well as this column to be able to get the elements that we want to take out. You see that, remember that vector is just one-dimensional, it's just long string like that, or long elements. So in this case, it is two-dimensional. That's why we are using two instead of just one value. In this square bracket, we are using two. So the first one here stands for the position of the row, and the second value stands for the position of the column. So in this case, now we're trying to access the element in the second row of the fourth column of this matrix that we just created, ABC, of this matrix. So that is just what we are doing. So let's run this particular code. So we can see that the element in the second column, sorry, in the second row, this is the second row, and the third and fourth column, sorry, counting, if you count it, you see that this is actually the element. So we've been able to access that element using the position of the row and the column. Just that. Very, very simple. So we can also do the same thing here. We can access the third row, sixth column element, which is 18 right here. So that's that for that. And going further, we see we can filter, just as we were able to filter vectors initially, we can filter matrices, simply because each column of a matrix is a vector. I hope that is clear. Matrices are two-dimensional, but each column is seen as a vector. So that's why we treated vector earlier to understand it, and then we are using it now. So just as we're able to do when we're doing vectors, we want to filter the matrices. So I created this variable smaller than 10. And then I want the values of these vectors that are smaller than 10. I don't know if this is clear. So, okay, let's actually run this. So let's check our variable. So we can see that in this matrix now, we've been able to filter out the numbers that are smaller than 10 in this whole matrix. So that's just what we did. Just similarly when we're doing the vector. So greater than 10, we can also filter numbers that are greater than 10 using the greater than or equal to, just as we learned earlier. So going further, let's see if we actually did that. Okay, so we see that in this matrix now, 13, 14, 15, 11, 12, and the rest are all greater than 10. So we're able to filter them out. just as we did in the vector, because each row, each column of a matrix is a vector. That's why we're able to do these things. So going further, we can change elements of vectors. We can change elements of the vectors if we want. We can modify or change them. The same thing, or edit them. So in this case now, we want to access the element in the second row of the fourth column. I want to change that element to 20. So if we come here, we'll see that that particular element in the second row of the fourth column is 10. So, but we want to change it to 20. So that's why we're doing this. So let's check to see if it actually worked. Okay, so we can see that it worked. We've successfully changed the value of that. So we can do the same thing here. We're changing the element in the third row of the fourth column. So let's check to see if it works. Okay, we can see that it also works. Initially it was 18, now it is 2. So that's just that about changing values. So we can add rows to an existing vector matrix. And we can also add columns. So that's just what we want to do now. So there's this function rbind that we can use to do that. We can use rbind function to add rows. That R stands for row, so it's just a short form for row bind. So we want to bind this particular vector 1, 2, 3, 4, 5, 6 to this ABC matrix that we created earlier. Remember, this is it. This is the ABC matrix here. So we want to add this vector now to the rows. So let's run this particular code and see, check this thing now. We see that, okay, yeah, it has actually added the rows. Initially, it will just add 3 rows, but now there is a 4th row with elements 1, 2, 3, 4, 5, 6. So we're able to do that with this rbind function. Can also do this, but in cases where we may try to maybe we want to add rows to an existing matrix, and then the matrix that we're trying to, the vector that we want to add to that as a row to that matrix, is the length of the vector does not correspond to the length of the existing matrix. That is the length of the columns of the existing matrix. Sorry. So whenever we are doing row bind, we must make sure that the column, the vector that we are adding has the same number of columns. Sorry, yeah, the same number of columns as the existing vector and matrix. Sorry. So we're able to do this because if we check here now, we see that our matrix has 6 columns: 1, 2, 3, 4, 5, 6 column 1, 2, 6. We're able to add 6 rows to it. So now we want to try and add 1, 2, 3, 4 to this particular matrix. But we know that we had our existing matrix has 6 columns. So let's see if that will work. So we are getting this one in again. So number of column of result is not a multiple of vector. So this is similar to what we saw earlier. This is similar when we're creating matrix with invalid, with values, with rows or columns that are not a multiple of the length, or the lengths that are not the multiple of the row that we indicated. So similar thing is happening here. So since this vector that we're trying to add as a row to this matrix has 4 elements, R automatically add the first two elements to it again to ensure that it's complete, and then we can be able to add it to the existing matrix. So it's just similar to what we did earlier. So that's that. So if we want to add columns to, we just discussed adding rows. So if we want to add columns to an existing matrix, there's another function, cbind, that we can use to do that. So the cbind, the C stands for column bind. So it's used to bind an existing row column, a new column to an existing matrix column. So that is just what it does. So when we are doing that, the number of rows of the existing matrix has to be the same with the number of the elements of the vector that we want to add to as the column to the existing matrix. So that is just similar to this. This one, the number of columns has to be the same as the vector, the element of the row that we are adding, and sorry, the element of the vector that we're adding. But in this case, the number of rows has to be the same with the element of the vector that we're adding. So I believe we can see the difference. So let me just select this and run it with the cbind. So we are adding a column. So doing that now, you see that this particular 1, 2, 3, 4, 5 has been added to this matrix. So that is just what the cbind and the rbind function helps us to achieve. It helps us to be able to add columns and rows to existing matrices. So going on, just as we learned in the vector, when we're treating vector, we can also delete or do away with a particular rows or a particular column of a matrix if we want. So the syntax is not too different from what we saw earlier, but in this case, we must ensure that since the matrix is two-dimensional and we're doing it row by column, row and column, so the first argument in this square bracket has to be the row and the second one has to be the column. So in this case now, since we are doing -2, so we are telling R that we want to do away with the second row of this column, of this matrix, but we want to retain the whole column. That's why after comma here, there is nothing after the comma. This indicates that we want to retain all the column. We don't want anything to happen to the columns. They should just be the way they are, but we want to do away with the second row. So that's just what this is. So let's see if this is working. So I'm running this now. So you can see that initially our second row was 7, 8, was this 7, 8, then, but now we no longer have the second row here. We've deleted it. So the same thing, in this case, we are deleting the column. We are deleting the third column. Notice the difference. This one is after the column. When we're doing for the row, it was before the, comma. This one is after the comma. When we're doing for the row, it was before the comma. This one is after. So after means column, before means rows. So we are doing away with the third column. That is just what this is. So let me run it and then check to see if it actually works. Okay, so you can see that initially our third column was 3, 15, 3, and 3. So we no longer have that here. Column 3 is gone. So that's just that. So we can delete. In this case, we only indicated the column -3. So since we did not indicate anything here, it means that we are retaining all the rows. Let the rows just be the way they are. Don't do anything with the row, but do away with the third column. Okay, so in this case now, we want to remove row 1 and column 2. That's why we use the negative symbol to do both. So this is the row, remember, and this is the column after the comma. So we are removing the first row and the second column. So let me run that and then check it. Okay, you can see that the first row, which was 1, 2, 3, 4, 5, 6, and 1, is no longer here. And then the second column, which was 13, 14, 15, 16, 17, is no longer here. Sorry, the second column, which was 2, 14, 2, and 2, is no longer here. First row, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1 is no longer here, and the second column is no longer here, which is this. So that's just what it is. So using the C, you can also delete, you can also do away with multiple rows and columns in a matrix using the C function that we learned. C. So we are just, okay, we want to bring it in a form of a vector. I want to delete those two rows. This is just what this thing means, this particular part. So we want to delete the combination of 3 and 4 row, the third and fourth row. That's why this negative is preceding this C here. And then we want to also delete the second and the fifth column. Want to delete the combination of the second and the fifth column. That's why this negative is preceding this C here. So we can check, we can actually do it and check to see if it's actually worked. So let's check the values now. We'll see that, yeah, it actually worked. We no longer have the third and fourth row as well as the second and fifth column. So I hope this is clear. It is very, very important, very, very important when we are going into advanced data frames and the rest. So moving on, let's discuss factor. So factor is a way to encode strings into numbers in order to optimize memory. So what this means is, when you're working with strings like these, characters and even numeric values, when you're working with them like that, they tend to occupy much memory, like in the RStudio in the RStudio memory. Yeah, let me put it that way. And you know that one of R limitation is that it works with the RAM. It reads to the memory, the random access memory. So that's why most people, is the limitation to RSHA. So in a way to optimize the memory, we don't want to choke our memory. We don't want to exhaust the whole spaces. And we want our codes to run fast, especially when you are doing things like machine learning. When you're doing things like machine learning, and then you have lots and lots of variables, lots and lots of columns that you're working with. So those columns, they consume to run, if an algorithm is used to, like you want to create a model, sometimes it takes time for that model to be able to run if the variables are characters, and if those characters are lengthy. So it consumes memory that way. So factoring characters is a way to be able to represent strings as a numeric single value in R. So instead of R to save all these characters in its memory or other lengthy characters, a single numeric number is used to represent those characters. So that's just what factors are. And we can use factors when there are certain number of distinct values in a variable. So I just created this example here, like when you have a variable that is male and female, you can make that variable to be factor, because you may have situations where, okay, you have a list of people, their names, and then you are computing, you want to create a variable to represent their gender. So you may have so many of them to be male and so many of them to be female. You don't want R to be saving all those things individually, like the characters in the memory. So you want R to be able to do something about it to ensure that our code or our model runs faster. So that's just it. So male and female, creating this variable gender, or of creating gender variable. I want to check the class now. We're checking the class. You see that it's a character. So the whole string is stored. In this case, it can be memory intensive, and when the characters are much, it can be memory intensive. So we can remedy that by converting the variable to a factor with this as.factor function. So that our code will run faster and the memory optimization will be good, like the memory will be optimized, and I will be able to represent all these male and female as maybe 1 and 0 or something else, or 2 and 3, or just anything that is not as lengthy as the main character that we created. So now we can use this as dot factor to convert this to a factor. So when we check the class with the class function, we see that it is coming out as a factor. So same thing here, I'm creating a vector of the days of the week. So I'm storing it in the variable weekdays. So we want to check the class now. We see that over here it is still a character. But if we want to work with things like this, especially when we're building our model, to make more sense, and it will help us a lot if we convert them to factors so that the code will run faster. That is why it is good it's a good practice. So class now, we should check the class now that we've converted it to factor with the factor function. It's not a factor. So that is just what it is. So also logical variables can also be converted to factor. So when we convert this to factor now, and we check the class, check the class, see that is a factor. But let's check the variable itself and see, as we converted it to factor. So you see that they are true and false, and the levels are true and false. So that's just what it is. So we are not just limited to only logical variables and then character variables. We can also convert numeric variables into factors. Like I created this variable here, the vectors 100 on 200 and so forth. So I'm converting it to the same as the factor function, and then I want to check the class, see that this is still, it has been converted to a factor. So we can check the frequency of each value of the variable of the factor that we converted. I don't know if that's clear. So like this particular test that I created here. So I want to check for 100 now. I want to see how many hundreds we have in this particular vector. And I want to see how many 120 we have and how many 250s. So we can do that with the table function. So the table function will give us the frequency of the distinct class of the factors, or the distinct value of the frequency of the distinct value. So in this case now, we see that hundreds, there are 300 in this vector, there are 3 120s in this vector, and there are 250s in this vector. So that's just it. So we can do the same for this week, the week variable that we created, the days of the week. So when we do table, we see that Friday appears one time, Monday appears one time, Saturday appears one time, Sunday appears one time, Thursday, Tuesday, and Wednesday. So that's just that. So going on, arrays. Okay, so this one we'll just brush quickly through it. We'll just rush it because for now I don't think we'll be doing anything with arrays. So array is a multidimensional array stores several two-dimensional data structures, i.e. matrices, and the matrix must have the same dimension. So we learned how to create matrix earlier. So arrays is just a way that we can save, we can store multiple matrices in one variable. That is just what array is. A combination of 2 or 3 or even 10 or 20 matrices. They are all two-dimensional. That is, they are all two-dimensional, but they are all stored in the same variable. So that is just what it is. So let me just quickly run this particular lines of code, matrix 1, matrix 2. I'm just creating this matrix the way we've learned earlier. So I want to create an array. I want to create an array of them. So I created this now. So array, you can create array with the array function. And then inside an argument, we'll use the data argument to pass in the matrices that we'll create, and then dimension to set the dimension of how we want the matrix to be in the array. So that's just what this is. So I'm running it. So let's check on our array. Sorry, let me finish creating this. Okay. Okay, so I'm sorry. Okay, so this is just a matrix. The matrix 1 and matrix 2 that we created, these are the matrices. This is the matrix 1 and this is the matrix 2. But now they are all inside this matrix, this maths variable that I created here. So that's just what it is, basically. So just like the way we're able to index, we're able to access the element in vectors and matrices. We can also use the square brackets to access elements in an array. So we can just do something like this. We want to access the second row of the second matrix, sorry, the second row of the second column of the second matrix. I don't know if that's clear. So the first argument here is the row, the second argument here is the column, and the third argument is the matrix. You know, there are two matrices in this particular array. So yeah, we want to check the second row of the second column of that matrix, which is this 14 that we have here. So I hope this is clear. So let me run it, and you see that actually the result is 14. That's just what it is. So going further, a list. So a list is a data structure that can contain objects of different type. So the list does not have that limitation that variable has, or limitation that vectors have and matrices have. This does not have those, or arrays. The limitation that vectors, matrices, and array has, list does not have those limitations. List can take on any type of data structure. List can take on arrays and vectors and matrices all combined together. List can do that. So we can create a list with the list function. So in this case now, we are creating a list with the vectors Danladi, Chidima, Ojo, Mohammed, and then the age. Okay, I believe this is clear from this particular part to here. I believe it's clear. We are creating, this is a variable. You know how we created variables initially. So I'm creating this variable name that has this vector to store this vector. So I'm also creating another variable age to store this vector, and gender and salary and manager. That's just what it is. So we are putting everything inside a list. So that's why we use this list, and then in brackets we are putting everything inside. So let's run this line of code and check the structure. The str function is a base R function that can be used to check the structure of a matrix, an array, or a list or a data frame. So we are using this function to check the structure. And if you check it, you see that it is actually a list. You see, a list, and it has age, it has name, it has age, it has gender, it has salary, it has manager as variables inside of it. So I can check the class. Okay, so the class here gives us a list, is a list. So going further, here we've not actually tested if the limit. We've not actually test to know if it's actually limited like the matrices and arrays and vectors. So that's what we want to do. Going further now, we want to add an array. You know, initially we added only variables, vector variables inside of the same length inside this list. So now we want to add an array. The array that we created earlier. We want to add this array, maths, that we created earlier into the list, because list is not limited to having only variables of vectors or matrices or arrays. It can take everything at the same time. So that's why we are doing this. So if I run this particular line of code and check the structure, let's actually see this. Okay, so let me expand this particular window. You see that the employees now, the first variable here, you see the Danladi, Chidinma, Ojo, and Mohammed. The ages, you see them, the gender, the salary, the manager, and then the array that we added. You see the array that has two matrices in it. You see how complex the structure can be, and list is taking everything. List is like housing everything, all of them. So that's just what it is. Okay, so going further, we can access each variable in a list using this dollar sign. So this is dollar. So the name of this list, we store this list inside this variable employees. So the name of this list now, we want to access it using this dollar sign. So employees dollar names gives us the name of this, like the name variable in this list. So we can do the same employee dollar salary. That way, you see, we are getting the salary. So we can narrow our indexing, or we can narrow it down to the particular element in the vector of the variable. I hope that is clear. I hope I'm not complicating the whole thing. So we can do that by using this square bracket that we learned earlier. Remember, when we're treating vector matrices and the rest. So we want to access the name variable of this employee list and the first element of that name variable. That's just what it is. So we see that the first element is actually coming out as Danladi. And that confirms what we have here. So rushing further, we can do the same thing for salary, the third salary, which is 22,000, and then so we can actually remove a particular variable from a list. We can remove that array now from the list. You can just say employee as the list name, dollar array that is in that list, and we want to assign null to it. That is, we want to delete it. That is just what that null there indicates. We're deleting it. So if I run it and check inside the employees, you see that we no longer have that array. We only have name, age, gender, salary, manager, and that. Okay, so going further, we can also remove a variable from a list. We can remove a variable from a list using this square bracket. Here we are doing it we are just assigning null to that particular list and then it disappears. But instead, we want to do the method that we have been learning, this square bracket method, and then using the negative to precede a numeric position of any variable that we want to delete. So we're doing that now. Let me run this line of code and then come back here to check. We see that initially manager, which was a logical variable inside that list, is no longer there. So now we only have name, age, gender, salary. So we've deleted the fifth variable out of that list. So that's just what it is. So accessing the object of the list, $, if the object of the list does not have name, I don't know if you get it. Like initially we created this list and then we created the variables inside of it. So if we don't want to create variable now, if we just want to okay, let me just create this list and put an array directly. I don't want to store the array inside a variable in that list. I just want it to come out as the array itself. So let me run this line of code. So we cannot use the $sign, this particular method, this $sign, to access the value, that is the array in that list anymore, because it no longer has name that we can reference it. It no longer has variable attached to it that we can reference it with. So we cannot do that. So that way we can now use another method to access any value, any object in a list that does not have a name. So we are using the two square brackets, and when we do that, we see that we have a we have the output is actually coming as the array of two matrices that we created. Okay. Oh, I see that someone is actually leaving us from the chat window. So we are rounding things up now, so you won't miss a lot. So thank you. Okay, so going further, so we can access this like this, and then if we want to channel this our access down to the element in any of these matrices like we did earlier, we can, let me just copy this thing here. You can just do something like this. Okay, so we're accessing the sixth object in that list, which is the array. So we want to further narrow this search down now and do something like this. So we are narrowing it down to the element. Remember how we're able to use this thing to index the array. So this is just for what we are doing here. We are just using that same method, but we are kind of combining it with what we have now. So that's just it. So that's just that. So basically that's what list is. So data frames, coming to the final aspect of this class, data frame is what we're mostly making use of when we start delving into the data science proper. The data frames or tables are things that is very, very important. They are very, very important. We know about them. We know how to maneuver them. We know how to do operations on. But that's why we discussed the vectors and variables and all that. All those things combines with the knowledge we have so far about all those other stuffs. Data frame is just a combination of them. So nothing is new. It's just what we know. We are just combining. Even some people call matrices data frames, but now I'll leave you to do your own research to like check what the difference are between a data frame and a matrix, and ordinary matrix like that. So a data frame is a table or a two-dimensional array-like structure in which each column contains values of one variable and each row contains one set of values from each column. So that's the simple explanation I can, like definition I can come up with. So if you don't understand that, yeah, we'll see more to it. So I just have this data set here to play with. Okay, this is a data set that is available for everyone. if you have RStudio, you have this data set. Iris is the name of the data set. So the head function here is like, okay, it's telling you want to like it's telling her that, okay, I want to see the head of this whole data frame. So head in this case is just the first six rows. That is first 6 observation. I can do 10. I can do 10. Yeah, I can say I want to see the first 10 with that same function, and to give me the first 10 observation. So that's that. So let's see how we can create a data frame before we terminate the class. So just as we've learned earlier, this is creating a vector. We know this. So I'm creating a vector phone with different brands of phone, and then I'm creating another vector price with the prices, and then I want to make a data frame with those vectors. So I use this function data.frame to create a data frame. So take notes, you can use data.frame to create data frames. So data.frame, the first argument is the first variable that we just created, the vector, which is the brands of phones, and the second one is the price, which is the second argument. This does not have any particular order. The price can come before the phone, and the phone can come before the price, whichever way you want it. So let me create this data frame. So let me see what it looks like. So we can see from here, let me actually clear this and check it again. Sorry. So we can see from here that we have the phone and the price, and they are in their elements corresponding in the corresponding form, like in a row form. Sorry. So these are the observations. These are called observations in data frames. This is the columns or the variables, and these are the observations. So we can check the class now. You see that it's a data frame because we created it with this data.frame function. So going on, we can I want to create another variable, another data frame. In this case, we are adding country. We're adding country to as a variable or as a column to the data frame. So let's see it now. Okay, we see now that we have phones, we have price, and we have country. So that's just that. So we can still check the class and see that it's a data frame. And we can use the same dimension, this dim function that we used in Matrix, to check the dimension of the data frame. So we see that, yeah, this is 6 rows and then 3 columns, 6 by 3. So it still does the same thing here. We can use the same structure that we used to check for list and to see the structure of this particular data frame devices that we created. So going on, we can access data frames the same way we accessed lists, vectors, matrices. Using this $sign, I want to access the phone variable of this data frame. Just the same thing we did earlier, and you see that the output Nokia, Infinix, Samsung, Sony, and the rest. So we can still even narrow our search or index down to particular element of a data frame. So I want to check the third price of this device's data frame. Sorry. Okay, sorry, I just did. Okay. So I want to check the third. I need to escape this particular. I've done. Okay. Okay, I've escaped it now. Sorry, it was just one kind of loop there that I entered by mistake. Okay, so I can narrow the search down to a price, a particular price, the element of like a particular price, yeah, of the price variable in the data and the device's data frame. So that's what I'm doing. So 1E00, let me quickly change this. There's an option in R that when you start seeing values like that, you can just edit it. Okay, so now let me rerun this code, and then you see that the third price is 100,000. This is similar to what we've been doing so far, no different. So we can also access a particular variable or a column in a data frame by putting the name of the column or the variable inside a column. So this is another way to access a data frame, a variable in a data frame, and you see we are still getting the variable. So we can use the index position as well. Like I want to get the first column of this data frame now. I'm doing it. So I'm still getting the same results because the first column is the phone. So now, just as we were able to do in the matrix, we can also narrow the indexing down. So we want the row 2, column 2 observation, which is 4,000. The row 2, the column 2 is the price, and the row 2 of that price is, let's see it. The row 2 of that price is 40,000. So that's just, it's no different from what we've been learning. And then we can modify or edit the value just as we're able to do when we're treating matrices. If we do this now and we check the devices again, the data frame, we'll see that the second, this initially was 40,000, now it is now 200,000. So it's similar. So we can also filter these things just the same way we're able to do these things. So this isn't, nothing here is new, I believe. So on this note, okay, the C bind that we did, and then the rest R bind. This is not new, just what we've been doing. So let me just keep true to this part that we have something new, this function as dot character. Okay, so when we're creating these data frames, let me actually run this code. When we're creating these data frames, R automatically converts some of the R automatically converts some of the columns to factors for us. So sometimes we may not want to use factors, we may want it to be characters. So that's why we can use this as dot character function, and then inside the bracket we'll pass in what you're trying to convert. So in this case, the devices the phone brands, R converted them to a factor for us when we created a data frame. So we no longer want it as a factor. So we want to change it to character and store it inside that same phone variable. So that's just what you are doing. It's nothing new. So someone asked the question how we can change the class, the type of a data. So this is it. So initially it was factor. Now we are using this as dot character to convert it to a character. There are other functions too. There is as dot numeric to convert um, object from other type to a numeric type. So that's just what it is. So this is the same as we were able to use the R bind to add rows to matrices. We can do the same in Dataframe. So on this note, I think we've come to the end of this class. But one thing I would like to talk about real quickly is no problem. We'll share this particular script in the group so that since there are comments and everything that you can just look through and it will guide you. We'll share it to the group so that you look at them and then get a better understanding. So thank you very, very much for participating. I really enjoyed the class. I hope you all did. So if you followed to this point, please just indicate in the chat box. Let me see. Okay, I can see Mr. Ojo followed. Thank you, Mr. Ojo. Thank you, Mr. Abraham, and thank you to every other person. Thank you, Chidima. So we'll share the script. We'll share the script. You'll get it either through, we'll share it through the email. We'll mail it to you. There are comments, you just follow it up, and it's very, very easy. So that our next meetup we'll be able to do with more advanced, like we'll be delving into the data science itself. This is just the tool, and we need to know how to use the tool to be able to work efficiently. So thank you very, very much. God bless you.